Yeah. Okay.
Yeah.
Then I will cover how SSL works. Okay. And the IPsec topic, we will be having a dedicated hour or day for IPsec when we will be configuring it on Palo Alto. Then I will explain you the logics of IPsec, how it works. Okay. So let me give you an example, like how these certificates, root CAs, and they really works. So have you heard of like any university? So Ebom, tell me, like, if the same scenario is in like in US or also. So we have a university, okay? So the main branch of university is here. So if you are studying in this university, okay, you have you have done your graduation and you will get a certificate, okay, your mark sheet that you are graduated, and here you will sign signatures of the university and their stamp, okay. Abom
Okay.
and
Yeah.
Prasad. Okay, if you have guys, like we have university, okay, when you we just go and take admission from there, then like suppose it's a 3 years of course, we completed our graduation. After graduation you will get a certificate that like Abom or Prasad has done a graduation or graduated from this university, and after that you will have signatures and stamp of university on your degree. Got it?
Okay.
So like how and after that you are taking that certificate. Suppose you are applying for government job, okay, and also you are going in any company, okay, to apply your job, they will ask your certificate, okay. Then how they will validate this, that this is an authorized or a valid certificate or not? Because might be like you have done graduation from there, okay, I took a copy of it, I did some editing, and after that I will have the same copy as you have, okay, but my name will be changed on it. But how, like, if then we are going to the same company to apply for the job, okay, XYZ company, okay, you are going with a legitimate certificate, I am going with a fake certificate. Then how this company will validate, like which, which certificate is valid, okay? Is it Abom or Prasad? Okay, how they will validate Abom and Prasad? Like you submitted your certificate to the company, okay,
By verification with the university.
Sorry?
By verification with the university.
Yes.
Yeah, they check with the school.
Yes, they will check with the school or university. Okay, you got it. Then this is, so the university in terms of certification, this is CA. Okay, certificate authority, and this is certificate. So if any server is offering you a certificate, how will you validate that certificate? You will check it with the certificate authority. A certificate authority, I have received a certificate. So can you validate, is it a valid or non-valid certificate? Got it? Any doubt about and Prasad till now?
No.
Okay. So now suppose like this is an XYZ university in like in US. Okay. So like this is a very big university, and it works across all the states in US. So how it will be very difficult for them to sign each and every certificate as at a single place. So what normally they does, they open their sub branch of university. Okay, sub branch. That means I am authorizing this university in a different state. Okay, if you are graduating and if your certificate like you are graduating and your certificate is signed by this university, then it is also valid, because it will sign this and it will notify to main university, hey, I have provided the certificate to this person ABC, and please update your database. Okay, so here it's a power of attorney. Okay, that university gave a power of attorney to some other sub university. Okay, their sub branch, that you can also sign certificate for, like for 5 states. Okay, so suppose in US, like you have so many states, so for 5 states, certificate will be signed by this university, and then we have another sub university. So another 5 state students, if they will study there, so their certificate will be signed by this like university, this sub branch of this university. Got it?
Okay.
So this is sub root CA. Okay, so what root CA is doing? Root CA is providing authority, okay, to a certificate, sub, like it's a kind of branch, okay, that they are opening. Hey, I am giving you the authority. If someone comes to you, you can sign that certificate, okay, and it will be valid. Understood?
Okay.
So now our, like how our, hierarchy for this certificate authority is. Okay. So hierarchy becomes this way: CA, the certificate authority, then sub CA. Although sub CA is not mandatory, the certificate can directly be signed by certificate authority, but like it becomes very difficult for the CA, okay, to manage everything. So what they do, they create the sub CAs, and that sub CA, it will, then we will be having certificate. Okay, so suppose Facebook, okay, Facebook is going, hey, I need a certificate for www.facebook.com. Okay, so we have different like DigiCert, like certificate authority. Then Amazon is also certificate authority. Then Google LLC. Okay, they are also certificate authority. Then we have VeriSign. Okay, VeriSign. Okay, so these are certificate authorities. So you can go to anyone. Okay, like we have so many universities, we can, it's our choice, like in which university we want to study. So the same way, there are so many certificate authorities available, okay, public. You can go to anyone to get your certificate signed, okay. So suppose you are going to DigiCert, the most famous, like people use. So you will go to the DigiCert, okay, you will, hey, I need a certificate. They will give you a certificate, okay.
Okay.
And then this certificate you can use on your server, okay.
Okay.
So any doubt till here? After that, we will, move to the SSL handshake. Then I will again explain this hierarchy, how the certificate gets validated. Okay. So you understood this hierarchy?
Yes.
Okay, great. So okay. Okay, this is your source and this is the destination server. Let's take an example of like google.com. Okay. So you type in your browser www.google.com. So first thing, what will happen, the TCP handshake, because we are using HTTPS and HTTP uses TCP protocol. So if we are using TCP, any application or any protocol that is using TCP, the first TCP three-way handshake will be completed. So it will send a SYN. Okay. Then the server will respond with SYN plus ACK. So this acknowledgement is of this SYN, okay, in the first packet, and this is the request initiation of the server. Then this client will respond back the acknowledgement. Okay, so that means their three-way handshake is completed. So far, so good. Now we are using HTTPS. Okay, so that means we will be communicating over HTTP, by using HTTP headers. What we are using as it means, it will be a secure communication. What it means, the HTTP packet, before the user will send the packet, it will be encrypted. Then it will be sent over the like network or internet. Okay. So what they will do, like who is the initiator of this request? Your system. Okay. So we call it client. Okay. And we call it server. So it's not that it will always be server. The person who initiate the connection, we call it client. Okay. So if the server is initiating any connection, so server will be considered as a client. Okay. So this is how that they use this terminology. The initiator of the request, we call it client. Okay, so this PC, okay, it want to communicate a secure communication. So what they need the keys, okay, so that we can encrypt the packet, HTTP packet, before sending it to the server, and server can also be able to decrypt it, and it will also be able to encrypt when the server is sending something to the client, okay, to the PC one. So what it will do, it will do the SSL handshake. Okay. So in SSL handshake, the first packet we call it client hello. Okay. Client hello. So what we take in client hello, that means, hey, it is offering. Okay. So the same as the TCP handshake. Hey, I want to create a SSL handshake with you. Okay. I want to do a SSL handshake with you. So what? Okay, so before that, let me just also do one thing. The certificate for google.com, okay, that we have got generated from the certificate authority. We will use that certificate, or we will import that certificate here, okay, on this server. Okay, and these certificate, they have two keys. One is public key and one is private key. Okay, the certificate has two keys. One is public key and one is private key. So you send the first packet, client hello, and in client hello, what we send, like there are few details, like it generates a random number, okay, list of cipher suites. Okay, one moment, let me think this. Okay, so you see here. So if you will see here, like the TCP handshake was done, okay, before the SSL handshake, the client hello. So it sent a SYN, we received SYNAC, okay, then it sent a acknowledgement. That means our TCP handshake is done. Then we have client hello. And also you guys can check the packet captures anytime. You do not need to take the packet capture. Just go to the Google, okay, SSL handshake packet capture cloud shark. Okay, this is the site. So whatever packet capture you want to see, just type it, and at the end just type cloud shark. So you will see this site, open it. You will see all the packet captures if you want to analyze, okay, how the traffic flow is happening. So you will get it here. Okay. So you do not need to replicate into the lab, then the packet capture, and then you want to just see it. You can do it. Everything is available on the internet. So let's come here. So in the client hello, just don't worry about, there are so many details are going, okay, those are really not necessary. Okay, all the details are not required. So what these details are, they will be used to calculate the key, okay, master key. So it generates a random number. So how it generates a random number, what is the current time, date, and it also generates a random numbers, and the combination of both these, it creates a number. Okay, it is a random number. Okay, it could be anything. Okay, and it also takes the TLS version. So if you see like SSL and TLS version, like 1.1, 1.2, then we have I believe 2 point something, that is out of, like, people are not using. So they uses this TLS version. So in the client hello, what we are sending, the version of SSL, a random number, and list of cipher suites. So here it is, like the algorithms that the PC, like suppose you from your computer you are accessing www.google.com. So your computer will send, hey, I support these languages, okay, these cipher suites. So it's the same way, like if I'm talking to Abom, okay, so Abom, I will tell you, Abom, I speak two languages, Hindi and English. So in which you are comfortable. So you know English. So what you will say, hey, we can communicate on English because you don't know Hindi.
Yes.
Okay? So this is the same way the system is offering its language, communication medium. Hey, I support these, I understand these cipher suites. You tell me which one, on which cipher suites you want to communicate with me. Okay, this is the same way. So this is the cipher suite. Okay, list of algorithms. So it's a combination. Like if you see here, we are using RSA with AES 128 GCM SHA-256. Here everything is same, but it is using ECDSA. Okay, the other parameters are same. So this is how it's a combination of multiple algorithms. Okay, so only important thing is the cipher suites, the TLS version when it comes to the troubleshooting, and also the server name. Please make a note of it. This is very important.
Yeah. I need that. Just go slowly.
Yeah. So the server name is very important. So what the server name is, this is where you will find for which URL the request is going. So although like it was tested into the lab, so they only, like they didn't set up any URL. They just access HTTPS over this 10.0.1.69 IP. Okay, that's why we see it. Otherwise, if you will send this packet to the Google, so you will see google.com. If it will be on facebook.com, then it will be the facebook.com. Okay, so if you are accessing youtube.com, then in the server name here, you will find youtube.com. So sometimes whenever we do the packet capture analysis, so how we can identify, because you can, if you are taking packet captures, you might see multiple SSL handshake, but how will you validate, like which, suppose you are, you are doing troubleshooting for facebook.com, but you see multiple SSL handshake, then how will you validate, hey, which SSL handshake is for facebook.com? So this is how you can validate. Just go to the client hello, okay, and then go to the server name and check here the server name. If it is facebook.com, that means this is your packet capture. Okay.
Okay.
Prasad, any doubt? This is very important, guys, when we do packet capture troubleshooting. And also this is also important when we do the URL filtering, okay, the URL blocking on Palo Alto Firewall. Like suppose we want to block facebook.com. So this is where the Palo Alto picks up the URLs.
Okay. You say the client hello and the server name and what else?
Yeah. So here the server name is it will be the URL. Okay.
Okay. I got that.
So okay, the other thing is TLS version.
Okay,
because
TLS
sometimes,
version.
yes, sometimes what happens, suppose your server is supporting the higher end TLS versions, but your system is not supporting. Might be your server is supporting lower end TLS versions, but you are sending higher end versions, so they will not be able to complete the SSL handshake. Okay. So TLS version, list of cipher suites, and the server name. The other things are like these are algorithms. You do not need to worry about it. Okay. You will never come across with such things. Okay. Yeah, then you send a packet, okay, to the server. Then it's the server responsibility to respond. Okay, so what server will do, server will, respond you back with the TLS version. Yes, I support this. Okay. And also it will also give a random number. Okay. That will be a different random number from the server end.
Okay.
Then, okay, it selected this cipher suite. You see?
Yeah.
In the client hello, there was a so long list, but here it selected this. The way I speak 2 or 3 languages, above on which language you want to, speak with me, then you will say, hey, I only speak English, man. Okay, the list that you have shared. Or might be you might know Hindi as well as English, but you say I'm comfortable in English. Okay, so let's communicate over this. Okay, so there is possibility. Okay, and even it is possible that the server supports multiple cipher suites, but it takes one of them. Okay, and along with that server hello, it is sending the certificate. You see, certificate. Okay, so that certificate is, let's come back. Okay, so the server is sending response back with server hello plus certificate, and it will also send you the public key. Okay, it will never share the private key. So
yes.
What it is? Okay, what it is, why it is sharing public key? So have you heard of or have you ever seen some lock, door lock, where you do not need a key? Okay, you just close it and it will be auto locked. Okay, then to open it you need a key. Okay, so this is the same way. Okay, let me come here. So it's a lock. Okay, I'm not good at designing, but let me just try. Okay, it's a lock. Okay, so you have 2 keys. Okay, for this lock. So if you want to close this lock, you need key 8. Okay, but with this key you can only lock this. Okay, you cannot open this. Then there is a key B. So the B key can only open, but it cannot close. You got it? You have a special lock where you have 2 keys. One key can only lock, okay, and one can only unlock. So this key cannot, it can only lock it, but it cannot unlock. This can only unlock, but it cannot lock. So you got it? So the same thing is happening. The public key that we have, public key can only encrypt the data. Okay, but to decrypt that data, you cannot use the public key. Okay, you will never be able to decrypt the same packet. Okay, with the public key. To decrypt it, you need the private key.
The private key. Okay.
Yes. Okay. So how it is secure? Suppose you are sending. Right now this PC, it does not have any way. So whatever it is sending to the server, that can be encrypted. Okay, because if you will see in our packet capture, the first packet, okay, that we have sent, we can see everything. Okay, what we are sending. Okay, so this is in normal text. Anybody can take the packet capture. Okay, and they will be able to see what you are sending. Okay, so what we need to create a key in a secure medium, so that before we suppose we are sending ABC here, okay, it will be encrypted. So if someone in between take the packet capture, they will not be able to see ABC. Suppose after encrypting this ABC, it became MNO. So if someone will take the packet capture, he will say, oh, this PC1 is sending MNO, but really you are not sending MNO. You are sending ABC. Okay. So what we are doing, we are creating a key so that we can, whatever we are sending, we will be able to encrypt it. So this public key, the server will send the certificate as well as the public key. So now here you receive the certificate. Okay. But now there is another question. How you will validate the certificate that I have received, it is a valid certificate or not? For Facebook, might be you are doing, suppose your DNS server is compromised. The actual Google server IP is 8.8.8.8, but someone hacked your DNS server. What it does, it created a DNS entry 1.1.1.1 for google.com. So when your PC is sending DNS request to your server is responding 1.1.1.1, a fake IP. Then your TCP handshake will be done with the 1.1.1. SSL handshake will also be done. And after that, you will enter your credentials. Suppose for Google account, you are logged into the Gmail or Facebook. You enter your credentials and they will be able to capture your username and password. Okay. Is there a possibility? Abom Prasad?
Yes.
Okay. So to avoid this, before we send anything, okay, before we create the communication, we will validate the certificate, because in the certificate you will see google.com. Okay, let me just show you. Although like for the Google you will see so many other things. Let's check for this. Okay, Cloud Shark, just go there. Secure connection, certificate is valid. Here you open your certificate, just go to the details, and here you will see okay, you see the public key. This is this public key of this Cloud Shark organization certificate. Okay, it shares the public key. Subject. Okay, do you see the subject? Okay, what is the CN here? www.cloudshark.org. So this certificate will be used by Cloud Shark. And here, if you will see the hierarchy, this is the certificate www.cloudshark.org. What is the subroot CA? R3. And what is its root CA is ISRG root X1. Okay, this is the CA, this is subroot CA, and this is the certificate. Okay, so now who can validate this certificate is valid or not? The R3 or ISRG root X1.
Okay.
Okay, so let's come back to here. So you the PC, okay, your PC received the certificate, but now how your PC will validate? So have you ever heard of certificate authority on system? Certificate store. Okay, do you see this is the certificate store on every machine? Okay, even on your mobile you will see the certificate store. So what the certificate store does, it keeps all the root CA and subroot CAs. You see, here it is. Okay, CA ISRG root X1. Okay, they are there. How we receive it? With your Windows updates, okay, your operating system update, you receive these details, the certificate from the operating system providers. Okay.
Yep.
So the certificates are already, the CAs are already there. So what it will do, it will, because whenever whenever we any certificate authority, they sign any certificate, they put their digital signature here. Okay.
Yeah.
Digital signature. So what your PC will do, it will extract that digital signature. Okay, it will check who's the signing authority of this. So from here you can check, okay, R3 or ISRG root X1. They are the signing authority of this certificate. So what it will do, it will, because in the certificate it store this root C or subroot C, they will already be available. Okay, they will extract the digital signature of those certificate and they will like they will do some calculation in background, and after that, if the results get successful, that means this is a valid certificate, and this root CA, it will confirm, yes, this certificate is signed by me. Got it? Because for the google.com, you will not have the duplicate certificate in this world. Okay. You will have the same only for google.com. It will be unique. Even the certificate authorities, they also keep updated these details, so the duplication will not happen. Okay. Otherwise, anyone can get the google.com certificate or facebook.com certificate, and you will have your account hacking on daily basis. Okay. So they do it uniquely. So once this digital signature is validated by this root CA that is available on your PC, if it is success, that means your PC will mark it as a valid certificate. Okay. So sometimes you would have seen in your browser, you will see here a red sign, not secure.
Have you seen it? Many times.
Yes. So if it is not secure, it means your SSL during your SSL handshake, the certificate was not validated by the certificate authority on your system. Okay. So most of the time it is that the certificate got expired or the certificate is not valid, but sometimes it is also possible that the certificate authority is not available. Okay. Although like very rarely you will have it, but it is also possible that the certificate authority, okay, on your local certificate store, it is not available. That's why your PC is unable to validate it. So in such scenario, what we need to do, we just need to export or download the certificate authority and import it on your PC manually. Okay, you can import it. So just right click over there, okay, and import. Okay, you see import. Select the certificate and next, you can import it on here. Okay. You can also import it manually. And how you can download it? Just go there. Okay. Suppose you want to download this, click on this R3 and I believe. Okay. You need to download it first. Okay, we can download the certificate. Oh, here it is. Just click here, export. See? Then you can save it and download. Okay, let me go to download. You see, I got the certificate here. Now you can import the certificate into your certificate authority. Got it? Okay, great. Let's move further. Okay, so now your certificate or your PC is validated. Yes, this is a valid certificate. Okay, and after that, what it will do? The client was received, and also if you see in the first packet, what we sent a random number. Okay, the client random number. Okay, so the client number was generated here. The client random number is here. You also send it there. Then the server random number. It generated a server random number. It also sent the server random number here. Okay. So now you have the same over there. So after that, you received a public key. So suppose your system, it will automatically generate a key. Okay. Suppose it generated a key password 123. Okay. So now what it will do, the public key that it has received, it will encrypt that data with that public key. Okay, it will lock that data. It will encrypt that data with the public key that we have received. So once the public key is there, Okay, you encrypted it. After that, you can send it to the server. And after that, here it is going into the encrypted form. Okay, if somebody will take the packet capture, they will not be able to see that we are sending password 123. Got it? Now the password 123, like the packet will be received, you have the private key. You will, decrypt that packet, and you will get the password 123. Okay.
Okay.
Got it?
Yep.
Now you have client random number, server random number, and the password. Here you have the same data. Okay. And even over the internet, nobody knows. So what they will do, they will just perform a algorithm with the combination of these three data, and the result will be same. And here the result will also be same. Okay. So suppose it generated a key Palo @123. Suppose it's output, although like it will be a like hexadecimal number. Okay. But just to help you guys to understand, suppose after the result of the calculation, you will get Palo @123, and here you will also get the Palo @123, because we have the same data and it will use the same ciphers, okay, that we have selected, and the result will be same on both ends. Got it?
Yep.
So this is how, by using with the help of SSL handshake, the client and the server, they generate the key randomly, okay, dynamically. You do not need to, because in IPsec, what we do, we share pre-shared key, okay, with the server over the email or a secure medium, okay, manually. So the person who's configuring IPsec on the other end, he will enter the IPsec key, and we are also doing the IPsec key on one end. But when you are accessing any site over the internet, then it will become very difficult that Facebook cannot share, okay, the private key or even the keys with each and every user in this world.
Yeah.
So for this, our symmetric key will not work. Okay. So have you heard of what is symmetric key and asymmetric key?
I heard that, but I don't know the difference.
Okay, let me tell you. Symmetric key. Yeah, Prasad, go ahead.
Symmetric key is the fixed key that which cannot be shared to anyone. Symmetric key is the multiple, like public key.
Okay, yeah, you are correct. So symmetric key means to encrypt a data or to decrypt a data, you will use the same key. Okay.
Okay.
So you have a lock, you have a single key. If you want to lock it, you will lock it with the same key. If you want to unlock it, you will unlock it with the same key. That is symmetric key. Asymmetric key means to lock up any lock, you will have a different key. To unlock it, you will have a different key. That is asymmetric key.
Oh, like the one we're using right now, public and private. Yeah.
Yes.
Okay.
Got it? Now, I think you guys should not, never have any doubt in symmetric and asymmetric in your life.
Yep.
Okay. So, so symmetric key. So in SSL, what happens? We are creating a symmetric key by the help of asymmetric mechanism. Okay. By the certificate. So SSL certificate, they use the asymmetric key mechanism. That means to encrypt the key, encrypt the data, we are using public key. To decrypt the data, we are using private key. That's why we are forwarding public key over the internet. So the client, when he is sending the data, it will use the public key. It will encrypt that data, and it will forward it. Because if someone will take the packet capture, they will use the public key to decrypt it, but no, they cannot. Because public key can only encrypt it, it cannot decrypt it. So then your packet will be received to the server. Only the server have the private key, so the server can decrypt the data.
Okay.
Okay. After that, they will generate, do the calculation, because they will be having same data on both ends, and the key result will be same on both ends. Okay. Now this key will be used. So whatever downloading or uploading that you will do, or data or the communication that will happen, they will use this key to encrypt the data. They will forward the data. After that, like server will use the same Palo @123 to decrypt it, And when the server is sending something back, server will use the same key, palo@123. It will send it. Then your client, it will use palo@123 to decrypt it. Then only this single key will be used on both end to encrypt and decrypt. Got it? This is SSL handshake. It took me a long time to understand it when I didn't know about SSL, how really it works. Because you on the internet, if you will go, you will only find that client hello, server hello, and after that everything is encrypted. So we really didn't know how it really works. So to understand this, first we need to understand how the certificate authorities and the certificate works.
Makes sense.
Yes, then you should know in certificate we have two keys, public and private key. If you understand that, then you will be able to understand how really the SSL works. It is very simple if you understand these logics, how certificate authority works and how the certificate public key and private key works. Any doubt? Any question?
And keep on moving. I don't want to go ahead of you because I wanted to ask, and then after that, each area create a master key. Is though that master key can be like a
yes. So we call
like
it
a
master
symmetry key. Yeah. Okay.
Yes. We call it master key. Okay. The final key that we will be using to encrypt and decrypt, we call it master key.
Okay.
Okay. So just don't confuse yourself. This is the master key. Okay. So by using the asymmetric key, we generate the master key, and then master key will be used. Suppose you are forwarding any data or the communication that you are doing to and from, everything will be encrypted by this master key, and your communication will be secured by SSL. Yep. Prasad, any doubt, any question?
No, it's very clear.
Oh, great.
Because yesterday I had gone through all the theory, the video, the same.
Yes. That's why I gave you. Okay, that's why. That's why I always give something. The topic that we are covering tomorrow. So at least if you will go, okay, you will understand. Even you will get familiar with the terms. Okay, might be you are not understanding the complete logic, but you will be familiar with the terms or the logics at least somehow. Okay, at some point. That's why I always give. Okay, just go and have a look over for it on Google. Yeah.
Really a good approach because it gives us an understanding. Yeah. And then when we come to you, you give a lot of detail, on what we are. Yeah, yes. It makes sense. Makes sense.
Okay, so now let's come to the packet captures. Okay, so the first packet, the SYN packet, okay, that we have. So in the SYN, if you will, if we just go through it, so SYN flag, okay, you see all flags are 000, only SYN flag is set. Okay.
Okay.
In the first packet. Then in the second packet, if we click here, so all the bits are 0, but acknowledgement and SYN is set. Okay. These are 1 and all others are 0. And then in the next packet, you will see we have only acknowledgement, but SYN is not set. Okay. So this is how in the packet capture the bits are set. Okay. So if you have any packet capture where you have reset, then your reset bit will be set. Okay. And others will be 0. Let me see if we have reset here. Okay, FIN. Let me show you FIN. So you see FIN. The FIN bit is set and this is the acknowledgement. So what this particular packet is doing, it is sending its O1 FIN as well as it is acknowledging. Okay. Connection finish. SYN means connection finish.
Yeah.
Okay. So once our TCP handshake is done, then we will be having SSL handshake. So in the SSL handshake, only the important topics are like the fields, which SSL version we are using. Okay. and the list of cipher suites, and also the server name, because sometimes people can ask you a question, okay, how can you identify from the packet capture that this request is going for that particular URL? Hey, from the SSL handshake, we will just open the client hello packet, and we will check the server name field, okay, server identifier, and from there we can get the URL name. Got it?
Yep.
Yeah, generally they ask this question, okay, when it comes to URL filtering question or the other stuff, okay, so never ever forget this. Okay, so it will send, okay, then you will receive an acknowledgement, like from there, then server will send the server hello with certificate.
Can you say me the once
Yeah.
again where, from where we can pick that certificate, like URL name?
Okay, URL name, just go to the client hello, okay, then open the transport layer security packet, okay, or SSL packet, then server name extension, okay, extension server name, then explore it, and after that you see server name here, because in this packet capture, like they would have done it in the lab, so they directly access 10 https 10.0.1.69, and they took the packet capture. So you can also identify like what user typed in the browser, okay, so like are they typing the correct URL or incorrect URL? So whatever they are typing, the request will go there, although like it will really not reach until unless you're like you're requesting to the correct server. Because if you will be using a wrong FQDN, suppose it's a facebook.com but you are using facebook1.com, so it will resolve the DNS, but you will never have DNS for facebook1.com, so even your TCP handshake will not get completed, okay, so you will not see the wrong FQDN over there, but whatever FQDN is going, you will see here, okay, the URL. Okay, and also, let me just explain it to you now. You will only see the original URL, okay? After slash, you will not see. Okay? You will only see, because this is the actual URL, okay? Because on one server, you can have multiple certificate, okay? Suppose you are, hosting www.cloudshark as well as www.xyz.com from the same server. But by the help of this server name, the server identifies, okay, this request is for that particular service or for that particular URL. Let me offer them that certificate, not the other certificate. Okay. Any question? Any doubt so far?
No.
Okay, great, man. Great. Okay, let's move. Okay, so here we have the certificate. So you will see the details, okay, till here. So that certificate, okay, that they offered the certificate. So the certificate size is 618 bytes. Okay, this is the certificate. So certificate authority, the validity. If you want to see the validity, okay, just click here. So this certificate was valid, till like it was generated on 2nd, I believe it is February. Okay, 10th of February 2015. Okay, and it got expired on 10th of February 2016. So from here you can also see the certificate validity timing. Might be the server did not renew the certificate. Okay, and today is, suppose we are in 2023, so if we take the packet capture for the same particular URL, and if we see, hey, the certificate got already expired, so there is possibility might be server is offering the wrong certificate, or you did not replace it. Okay, so this is all, we also use it during troubleshooting. Okay, then subject public key. So here is the public key. Although like we really do not worry, okay, and even you cannot do any troubleshooting on this public key. So it is being used by system. Okay, they have the functions or programs already available on the operating systems. They perform the algorithms in background to validate the signatures from the certificate to the certificate authority or subroute CA that we have on our system. Okay. So once we receive it, after that, okay, the packet that will be sent, you will not see, okay, client key exchange. Do you see key exchange? That means the key is exchanged. So what after that you will not see, okay, what exactly is sent, because the client has encrypted the key with the public key. Okay. So you will not see anything. So you only see the basic things like what is the TLS version. Okay. So you see encrypted handshake message. So the next packet that we are sending, it is encrypted. So nobody can decrypt it. Okay. So your handshake is done. After that, your actual data will be exchanged over the internet. Got it?
Yep.
Yeah,
Yes,
this
got
is
it.
how you can, this is how you can read the packet captures as well. Okay, suppose for the first packet, you see frame, okay, you would not need to worry. Ethernet frame, okay. So the most important fields that I explained you is destination MAC and source MAC, okay. So the source MAC is like, this was taken from the Apple, okay, Apple laptop. So this is the destination MAC and this is the IPv4, okay, the hexadecimal, the type. So what it is saying, like what packet I'm carrying. So it's an IPv4 packet. So the Ethernet header type is mentioning IPv4. Okay. Then we can open this IPv4 packet. So in the IPv4, what are the important fields? The source address, destination address. Okay. And you see, this is the source address. This is the destination address. Okay. Also the protocol. It is giving TCP because in the transport layer, the packet, okay, the IP header, it is carrying the TCP header, okay, TCP packet. So it is mentioning this is what I'm carrying, okay. And here the layer 2 is saying what I'm carrying IPv4 header. So here we have IPv4 header, and this IPv4 header is saying, hey, I'm carrying TCP. So here we have TCP packet. Got it? And also, you see, don't fragment. So this packet, this bit, the flag on this layer on IPv4 header, this don't fragment bit is set. It means nobody can decrypt this packet. Nobody can fragment this packet.
Yeah, we saw that yesterday. That was 0, 1, and 2.
Yes. So nobody can fragment this. And these days, fragmentation is not good for the network. Okay. And most of the application these days, they use this do not fragment bit set. Okay. Because segmentation is good, but fragmentation is not good. Segmentation happens at TCP layer, okay, our transport layer, but fragmentation happens at at our network layer. So let me tell you why fragmentation is not good. Because what TCP does, okay, TCP track the sequence number and acknowledgement. Okay. So if something is sent and it did not receive the acknowledgement of, suppose you sent the data from 0 to 1400 bytes. Okay. The data was sent here. So you will receive the acknowledgement of 1400. Okay. So what TCP will think? Yes, the 1400 has been delivered. Now let me send another. Then you will send 1400 to 2800. Okay. So this, once the packet is delivered, it will acknowledge you. Yes, I have received 2800. Okay. So TCP is tracking these details. But suppose you are fragmenting the packet. So there is a packet, okay, at layer 3, what you did, its size is 3000. So what you are doing, you are using 1200. Okay, sorry. Okay, 0 to 1200, then 2400, and then it will be 3000. So you are chopping the single packet into 3. So suppose the first fragment you sent. Okay. So the fragment is received from 0 to 1200. So there is no acknowledgement here. Then you send this packet. Okay, you sent this packet. This packet, suppose it got dropped in between. After that, because your system will automatically send this packet. So this packet will also be in buffer. Okay, but this packet got dropped. Okay, and we do not have any mechanism in IPv4 or in IPv4 header that it will acknowledge that I did not receive this fragment, it got dropped. So what will happen? This packet and this packet, okay, they will remain in your buffer. Okay, and suppose there are so many packet drops are happening, that means there will be so many packets. Okay, they will be in your buffer and your buffer will be filled. Okay, and you can have outage. Okay, your system might crash, your firewall might crash. Okay, and even your server, whatever device, okay, even your router, if you have any router and you have such scenario, so they will crash. So what they normally, program it, they, keep a timer. You can only keep a packet for, like 2 seconds or 5 seconds or 10 seconds. If you will not receive the complete fragments, just drop it. Okay.
Okay, I have a question about that.
Yeah.
Maybe we don't want to go out of the subject.
No,
we do fragmentation because the MTU is 1500. Maybe
yes,
the package was bigger. That's why the
yes,
fragmentation take place, right?
yes. Okay, but these days, what happens? Most of the application they use TCP. Okay. So in TCP, what we do, we calculate the MSS.
Okay.
Okay. So MSS will always be lesser than your MTU. Suppose your MTU will be 1400. Okay, because these days the standard MTU that over the internet that they follow is 1500. Okay. So 1500 means if your TCP header, their normal size TCP header is 20 bytes and IP header is also 20 bytes. But if they are using option, they will increase. Okay. So the MSS, the maximum size, it will be calculated according to that. So it will be calculated, suppose 1400. 1400 plus 20 plus 20. Okay. And suppose the TCP header, okay, it might be 2040 and your total size, 20 plus 20, and it will be like 14 40 or 50. Okay, so the MSS, make sure that you are not sending a packet over the MTU. And also those applications, they said do not fragment. So if it will reach to a router in between that has only 1400 MTU, so that means the router will check, hey, do not fragment is set. So what it will do, it will drop that packet and it will send an ICMP response that packet exceeded the MTU size. Okay, so we could not fragment it. So what your application will see, hey, we are receiving, like if we are sending 1500 bytes of packet, we are receiving this error. So what they will do, they will decrease the size of packet, okay, and they will send the packet again. So like suppose they sent 1450, okay, but again we received an ICMP error. That means, hey, this is also not the enough. We need to again decrease the MTU. Then they will send it 1400. Okay, so like it will go to 1400. In 1400, you will not get any error and your packet will be delivered to the destination. So it means my path MTU will be 1400.
Okay, makes sense.
Okay, so this is how the MSS works. And in most of the scenarios, you will see do not fragment a bit set, because these days application uses this. Because if they are already using TCP, that is giving the guarantee, then so they are chopping packet. They want to chop their packet at transport layer instead of IP layer. Okay, the network layer.
Okay.
So that's why they do it. And sometimes even when I was in TAC, we used to get cases where customer was saying, hey, we have very slow speed, and the CPU utilization of the firewall and memory utilization is getting very high. So the first thing that we used to check is the fragmentation is happening or not. We used to check their counters of fragments. So if there are so many fragments of fragmentation happening, that means, hey, there is an issue in your MTU. So please go ahead and check your MTU first. So 99% they used to get the issue of MTU. They correct it, and after that their issue, it got resolved.
Yeah.
Okay, so that's why fragmentation is not good, segmentation is good. Okay, they use path MTU. They send high size packet, then they keep on decreasing it. Okay, yeah, that's it. Yeah, we are done with SSL and the certificate authority. You guys, understood the logic. Okay, how really it works. So from Monday, we will be covering the SP3 architecture. Okay. Or Palo Alto, just go to the Google and search for it, and just try to read it once. Okay. Then I'll tell you simple way, then you will understand it. Although you do not need to write it in the exam, you just only need to understand the logic. Okay.
Okay then.
Then I will cover life of a packet.
Okay.
So what is life of a packet means whenever the packet enters to the Palo Alto firewall. Okay. So how the Palo Alto process it. Okay. With each step, at each step. Okay. I have first I'll explain this. Okay. And if you guys will be able to understand it quickly, then I'll show you a deep architecture of this. Okay, I have it. I got it from TAC. Okay, I do not have it publicly, so even they don't have it publicly available. Then I will explain when the packet enters to the interface of the firewall, what firewall checks. Okay, it will do the sanity checks. It checks the layer 2 header, layer 3 header, layer 4 header. Okay, if it is a tunnel packet, okay, and tunnel is terminating on the firewall, then it will decrypt that packet first. Then it will again send. Then it will check, do the same sanity checks again. Then it will send to the firewall. Then it will check, is it a first packet or we already have a session for this? Okay, if it is first packet, then it will send it to identify the parameters. What parameters? Like, do I have routing for this packet? Do I have a security policy? Okay, and do we have any NAT policy? So it identifies all the parameters. Once everything is identified, then it starts processing that packet. Then Palo Alto has the app engine to identify the application. Like, is it an SSL application? Even in Facebook. So, the best feature of Palo Alto is user ID and the app ID. Okay. So app ID means you can have control on the on the user traffic. Suppose you want a user to access facebook.com, but you don't want them to call anything. Okay. Suppose they are in your office, they connected to your LAN office. Okay, office LAN. They are accessing facebook.com. Okay, you want, okay, let them access Facebook, man. That's not an issue. But you don't want them to make a call, okay, on Facebook. You don't want them to play game on Facebook. You can block that. Okay. So this is that how the granular Palo Alto is. Okay.
Okay. Okay.
So like we will also see that, and then
it is only we can block this one by clicking that.
Yes,
right?
we can.
Marking.
Yes, sorry.
By marking, right?
Yes, in the security rule, we can block it.
Okay.
Yeah, the application ID Palo Alto, what they did, like they created on behalf of the signature, because on the internet, everything goes in headers. Okay. So if you are sending something, it attach a header, okay, and then it forwards the packet. So what Palo Alto did, they, did some research and they identified the signatures. Okay. Suppose for video call on Facebook, okay, like it keeps this header, so that will be the signature. So if Palo Alto identified this signature, it means this is a video traffic from Facebook. Okay, this is a video traffic from Zoom or any other application, whatever application those are available on Palo Alto, and they created an application on behalf of those signatures. Then it depends on you if you are creating security rule, if you are allowing those application and you are denying it. So Palo Alto will take the action according to your security policies. Okay. Then it does the content inspection, IDS, IPS. Okay. And if you're doing decryption, then it will do the, deep, inspection on the packet. So here, like when we forward the packet, okay, when the packet is exiting the firewall, like after doing all these checks, if you are applying QoS, yes, it will do it. If even the firewall is receiving fragmented packet, it will assemble them again. And then if the packet is tunnel traffic, so it will tunnel the traffic again. So it means like it will encrypt the packet again and it will forward it for the, to the peer. Got it?
Yeah.
So this architecture says like, hey, if I'm receiving something, so it's the same way. If we are eating something, so how our body is processing at each and every body part, okay? So the same thing is happening with the Palo Alto and even every device in this world. If they are receiving something, they are processing, they have different components, okay? Which particular component is doing what? So that is the life of a packet or life of a food in human body. So we can say this, okay?
Yep.
Okay, yeah, that's it. And guys, also one more thing, like I heard, you guys will be, setting up your lab on your laptops or on your systems.
How do you proceed on that?
Okay, although I'm not sure like what discussion that you had, but I always because the lab that you will set up on your system or on your laptop, it will be unlicensed firewalls. Okay, so you will not be able to learn troubleshooting because you will not see the logs. Okay, suppose you applied a security rule and after that you will not be able to see any logs on firewall, on the unlicensed firewall. Okay. But the most important thing on Palo Alto or even on any device is how to do the basic troubleshooting, how to check the logs. Suppose you are working on the firewall and user says, hey, this is not working. So you need to learn that, to learn that basic troubleshooting is very important.
Okay.
Because configuration, you just, go to Google and mention how to configure a security rule, how to configure a net rule, how to configure global protect. You will see everything. Okay, step by step, you just post the video and just configure it. You can configure it. It is very easy.
I had configured already server. I had installed one server. In the server, I had already installed a Palo Alto also. With a EVM like, right? Do you know that one?
Yeah, is it licensed?
No, I didn't know that one. This is the one type of simulators.
Yeah, simulator, it works. Okay, that is fine. Like if you have a VM firewall and the hardware firewall, no difference. Okay, no difference in troubleshooting and the features. Almost everything is same.
Mostly we will use Cisco and Huawei for this one. For troubleshooting, I will use that one. I had got the that one was the image of that Palo Alto, and I updated in that one EVM. Right now, I can open the EVM in the CLI mode in the Palo Alto. You can open it. I got my point.
Sorry, I didn't get.
I can able to open the Palo Alto virtual machine with type of simulator for practice only, not for the live.
Yeah, for practice only. So do you see the traffic logs and URL filtering logs?
I didn't open it until now. Basically, I had opened the working on it. I can able to open the Palo Alto or not.
Yeah, okay. So let me explain you one thing. Okay, although I recommend, because here the hands-on experience is very important. Okay, it plays a crucial role to learn any product. Okay, not only firewall, the other devices if you want to learn. Okay. So if you are not doing lab properly, okay, so there will be less chances that you will learn that product, okay, that much, because you will have the recordings, okay, you can watch them again and again. So it's the same thing, like you want to learn how to drive it, okay, so you can sit on the side seat and you can watch someone, oh, this is how he's driving, he's using accelerator, gear, he's changing, okay. But if you will sit on driver's seat, okay, then it will be very difficult to drive the car, okay. So to see something, okay, oh, now I can drive this, okay, it is very simple. There are only few things that we need to use. But when you actually drive, okay, then it becomes very difficult, okay. You will not be able to use them properly. So the same way goes with the labs. So if you are learning Palo Alto or even any product, if you are watching the video, oh, this is very simple, okay, we will use this command, okay. But when it comes in your hand, okay, you just go ahead and configure it. We just go ahead and troubleshoot it. Then it becomes difficult for us. Okay, we miss some step.
I agree with you.
Okay, so that's why I always recommend the lab. Okay, if you guys have a license lab, that is good. Okay, you can do it. But if you don't have it, okay, just let me know, because Prasad and you guys both works in different time zones. Okay, so you can take one lab as well. Okay, and if you want to take separate lab, then you can take the separate lab as well. Okay, so it will cost you around $36, okay, a month. So it depends on you guys, like how you want to buy your individual labs, okay, for 1 month, or you want to go with the a single lab.
Because we are in the different time zone. For instance, when you say we're going to talk on Monday, here it's going to be like Sunday night, I believe.
Yeah, so here it is day. So it's 11:14 in the 14 a.m.
Yes, you see, here is what time is it? It's almost oh shoot, like 1 midnight, 11 or 1 o'clock. So I believe I'm going to take just a sample. We cannot take both. I can take a simple one. If you can send me the information how to access that and pay, I will do it.
Okay, although it's not with me, okay, even I also take lab from them, okay, because the Palo Alto that is very expensive, okay. So even I don't have it personally, I also take lab from them, okay. It's a vendor that only provides lab for almost all the things, okay. So I'll check with them, okay. They can schedule a demo with you how you can access the lab, okay. So it will be a RDP machine, okay. So they will give you a username and password. They will give you an a host name. You can just RDP it, and after that in the lab you can add. You will get 2 licensed firewalls, okay. And after that you can add routers, okay. You can add PC, you can add server as well, because that will be server will be used for you for our user ID lab. And even if you want to manage the Active Directory, like you want to create few users and then you want to validate the authentication, then the Active Directory will be used, okay. So I would recommend you guys, okay, so to take it. Otherwise I will complete the class, okay. But guys, let me tell you one thing, okay. Teaching is not my profession, okay. I'm already working as an senior consultant in one of the company, okay. I'm already earning so well, but I like teaching. Okay, that's why I take 1 or 2 batch. Okay, so like these guys, they are, like we know each other, so they always come to me, Rishi, do you want to take that batch? Okay, then it's my hobby. Okay, that's why I take these batches.
That's
So
good. That's good.
my main purpose here is like to help you guys. If I'm teaching you that, I want you to learn it. Okay, so after this 1 month of time, okay, if you will go for interview, or if you want to work on the Palo Alto, that you will have enough confidence. Yes, we can work on it, we can do the basic troubleshooting, okay, better than the others.
Okay.
Okay, so it's my personal advice that you should go with the lab. Okay, rest depends on you, okay. I'm not forcing you guys, but that is, because I gave you a logic, okay, why the lab is important. So now depends on you guys. So tell me, like, you want to take one lab, okay, so it will be around 36 to $40 it will cost you, okay, but I'll tell them, okay, hey, we need it, and you both guys can discuss to each other and how you want to proceed. Prasad?
Yes, sir, we will discuss on a bit later.
Sorry?
We will both discuss on a bit later.
Okay, yeah, you guys have your numbers, okay, so you can discuss it, and you just take it, and you let me know, okay. So I'll ask them, and we will book that lab when it will be required, okay, because in next week, first 1 or 2 days, we will be covering up our theoretical part, and after that, when we will start our lab, okay, the practical topics, then we will start it, so you guys will utilize that 30 days in a well-versed way.
Yeah, makes sense. So
is this similar to your work from troubleshooting?
Sorry?
Is this troubleshoot I'm already in a simulators, right, regarding this Palo Alto and everything. Does not work for the practice?
No, like I believe no, because they said they didn't included the lab charges in it, okay, because I believe they had discussion with you, like they will be setting up lab on your systems, okay, and that will be unlicensed, okay. So like it has happened the same way, okay, in the previous batches, okay. So they don't.
I'm asking you that I already installed everything in the server, the cloud server, not a laptop. We are the ISP, right? That's why we have maintained the cloud server with our own. In the server, I had already placed one of the simulator, and we are testing already. Who Cisco is working on that one. At the same file, I had already configured Palo Alto network also, but I didn't. I had kept the network. Didn't log into the Palo Alto device because I'm not having any idea on that one. That's why I didn't log in. But it's in the CLI mode. Is it right, or we have GUI mode also?
Yeah, GUI mode. Palo Alto is a GUI mode. Okay, that's its main strength. Okay. So you can do most of the things from the GUI. Okay, so although like if it will not be licensed, okay, because when you install the Palo Alto image on any simulator, it will be unlicensed image. Okay, so you can configure HA, global protect, or these things, but the traffic logs, okay, the logs that firewall is generating, you will not be able to see them. Okay, and logs are very important while troubleshooting, because if a security rule matched or it is not matching, okay, what is the error, the URL is getting blocked or not blocked. So unless you don't see them, you will not be able to troubleshoot. Okay, how you can identify? Because security rule configuration, it is very simple. You configure source IP, destination IP, application, that's done. But if it is working, not working, and if you want to check what if I'm not allowing this application, how the firewall will behave, okay, and how the logs will look like, then you will not be able to see it.
Okay, share me the location, share me this URL and everything. I will go through it and I will require it. Take it.
Yeah, that's one I was asking Rashid. I'm like, you're gonna be like a hand holding here, because like me, or maybe I don't know, maybe Prashashin know more about that, but I don't have any information. You give us a link, and then I'll go ahead and see how much you can pay the license, monthly payment.
Yeah,
And then
I'll give you a contact number. Okay, you can
okay.
directly connect with that person. Okay, and if you are able to negotiate it, that's good. Okay, so you say I need 2 licensed, firewalls. Okay, and also, Prasad, I'm not sure. Like as you are saying, you already have a server or firewall available. So they also provide licensing. Okay, so around same charges, they will give you 1 license for 3 years. Okay. So around $40, they will give you 1 license, Palo Alto license for 3 years. Okay. So you do not need to buy 2 licenses. Okay. Just take only 1 license and use it for 3 years, not 1 month, because the lab is only available. Because if you already have your server and even you have your system, okay.
If required, also I can get the hardware of the Palo Alto. If any, because I'm in the field of networking, right? I can request any of my client to arrange the Palo Alto for the troubleshooting.
Oh man, that will be very good. Okay.
I will try for that because I didn't know who are having the Palo Alto devices. Let me check it out today and I'll update you tomorrow. Okay.
Yeah, that will be great. Okay, if you can do it. Okay.
What is the basic version we record? Basic model number? Should please share me that one. I will check.
Yeah, any Palo Alto firewall. Okay, so like the GUI features. Okay, everything is same. Okay, it's just their hardware.
I had that for 65,000. They are getting the second-hand firewall. Second-hand Palo Alto is ready to get.
65,000. Which model?
I didn't know model. I didn't check with the vendor regarding this.
Okay, so make sure you ask them the licensing. Okay, because their hardware is not that expensive, but license is very important.
It's already used firewall and it's a license also having, because we will regularly buy the Cisco Huawei product from them. The vendor of us supplying many things to us. We can deal with it.
Yeah, let me know the models, because there are some models. Okay, those are already end of sale. Okay, like 3000 series, and their 200 series, 220 is also end of sale. And
end of life. Okay.
Yeah, they are already end of life. Okay, so I believe like 220, that is 200 is already end of life. 220, it is end of sale, but they are yet to end of life. Okay, like Palo Alto is still supporting them for, like, they have some time frame, because end of sale means they stop selling those products. But if they already, suppose like July is end of sale of one of the product, but suppose I bought it today, so it means Palo Alto cannot stop supporting after 1 month. Okay, so at least they will give me 2 years time to support it. So
let me check and get back to you.
Okay, so just give me that model, and if it is already licensed, and if you are able to arrange it by yourself, then that is great. Okay, and Abom, just let me know. Okay, so like
just send me that information and the phone number.
Yeah, I'll send the WhatsApp link of that person. Okay, you just connect with him, and I'll share the details. Yeah, and he will help you on this. Okay, to get the demo range and everything. Okay.
Thank you.
Yeah, thank you so much for your time, and we will connect on Monday. And if you guys get time, then have a look at SP3 architecture and also life of a packet. Okay, just try to read it, but we will be covering it on Monday. Okay.
Okay.
Okay. Thank you so much for your time, and have a nice day.
Thank you for your time too. Bye.
Yeah, bye-bye.